in this one, we're doing something that is very similar to what you did in grade 9. Last year, you were asked to find the equation of the linear relation. We give you a point, or sometimes we might give you 2 points and ask you to find the equation of a line. So you would solve for the slope, solve for the y-intercept, and then you have the equation of line. So we're actually going to do something very similar in grade 10. We're not trying to find the equation of a linear relation. We are going to give you some information, and then it's your job to find the equation of the quadratic relation. Okay, and I would argue it's actually a little easier in grade 10 because you have these different forms that are very useful. Okay, so in grade 10 we study quadratic relations, and we learned that we can write the equation of quadratic relation in 3 different ways. So we have the standard form, which we hardly talked about. Okay, we're going to talk about it later. Standard form, we have vertex form, and we have factored form. Okay, so just to refresh your memory, standard form is ax squared plus bx plus c. Vertex form is great. Okay, we were able to extract the vertex. From vertex form, we're able to state the transformations from vertex form. We know if it's opening up or down. We know if it's going to be a narrow or wide parabola. You know so much from vertex form. Factored form's not bad either. Factored form gives you the zeros if you study the factors, and you can just get the same a value here, right? So the factor form is pretty good too. Okay, so what we're going to do, like I said, is we're going to give you information, and it's your job to build the equation, just like last year. So before we build it, we're going to tell ourselves or ask ourselves, which form should we build it in? Should we build it in vertex form? Should we build the equation in factor form or standard form? So if I give you the vertex and a point on the parabola, okay, now if I give you the vertex, you know what? You should use the vertex. Oh, it's vertex form. Okay, if I give you the vertex and a point, let's use vertex form. If I give you the x-intercepts and a point on the parabola, we should use factored form, because the x-intercepts will allow you to build the factors of factored form. What about vertex and x-intercept? If I give you the vertex and the x-intercepts, vertex form or factored form. Okay, it's really up to you. Vertex form or factored form. What if I give you the vertex and y-intercept? Well, if I give you the vertex and the y-intercept, that's basically like scenario A. Vertex, just the y-intercept is a special point on the parabola. So if I give you the vertex and a y-intercept, you still build the equation in vertex form. What if I give you 2 points on the parabola? Impossible. You cannot build the equation of a parabola. Or, yeah, you can't build the equation of the parabola if I give you 2 points, unless one of them is the vertex. Okay, I can't build the equation of parabola unless one of them is the vertex. And I really want you to think about this quickly. So just plot 2 points on the Cartesian plane and ask yourself, why can't I just graph a parabola using 2 points? I don't want to spoil it, so I'll let you just think about that. Okay, for F, y-intercept and point on the parabola. Y-intercept and point on the parabola. Wait a minute, that's just like scenario E. Scenario E. This 2 points on the parabola, y-intercept and point. Y-intercept is just a point on the parabola. It's the point where it crosses the y-axis, but it's still a point. So really, scenario E is the same as scenario F. It's impossible unless one of them is the vertex. Okay? Alright. I like saying unless. It reminds me of the Lorax. Anyway, so develop the equation of the quadratic relation based on the given information. So I have the vertex and a point. So you know what? If I'm given the vertex, I'm going to build it in vertex form. So let's remind ourselves, vertex form looks like this. So I know what h and k is, okay? I don't know what a is. So our goal, our mission here is to solve for a. So let h equals 3, k equal -5, and I'm going to sub in the point 0, 9. And after I do all this, you're going to say, oh, it's beautiful, because you have an equation which allows you to solve for a. And once you have a, you can rewrite the equation. You have the equation of the quadratic relation, right? So look at that. That is a grade 9 equation. It's a linear equation. So please, I'll show you a very common mistake that students do. So this is 0 minus 3 is 9a. Students here go crazy, right? 9a minus 5 on the right side. And then the next line, they write 4a. Please don't write 4a. You have to rearrange and solve for a. So add both sides by 5. I will show it. Okay, then you get 14 equals 9a. So a is equal to 14 over 9. Okay, please, you have to realize these are not like terms, okay? So just practice a few times and don't make a silly mistake like that on the test. Okay, so I have a now. It's weird, but it is what it is. 14 over 9, x minus 3 all squared, minus 5. Okay, not very pretty. Let's try again. Okay, so here x-intercepts at 0 and -3 and passes through the point 1, -3. Now this time they gave me two x-intercepts, or the x-intercepts, and it passes through the point 1, -3. So this time I'm going to build it in factored form, okay? Based on what they gave me, I'm going to build in factored form. I have no clue what the vertex is, so I can't build in vertex form. So let r equal 0, s equal -3. Okay, remember r and s are your zeros, right? So r and s, and sub in the point 1, -3. Okay, so if you do that, you'll get something pretty. 1 minus 0, 1 minus -3. So let's clean that up a bit. 1 minus 0 is 1, 1 minus -3 is 4. So 1 times 4 is 4. So a is -3/4. So just like last time, you know what a is, you can write the equation. If you have the zeros, you have the factors, right? If the 0 is -3, your factor must be x plus 3. Because -3 plus 3 will make your factor equal 0. You just have to really think about it. Basically, you have some information and you have to reverse engineer the equation. Because usually you have the equation and you extract information from the equation. But now you're reversing that process. Anyways, C. You have the vertex, x-intercepts. So this one's actually really interesting because you can build the equation into vertex form or in factor form. So I'm going to do it both ways, okay? So first I'm going to build it in vertex form. So let h equal -2, k equals -2. Sub in the point, doesn't matter, 1, 0 or -5, 0. I'm going to choose 1, 0. So here would be, this is 3, this is, so rearrange, so a is 2/9. So therefore, there, that's the equation in vertex form. Now I'm going to build it in factored form. Let r equal 1, s equals -5, sub in the point -2, -2. I can sub in any point. Now this point is a very special point, but nonetheless, it will work beautifully. And you can see something very interesting. I don't want to spoil it, but Oops, I made a mistake. That's why. I was wondering, I didn't see my really cool effect. So that's why. I knew I made a mistake. Hey, what do you know? It's the same A value. When I made that careless mistake, that's when I knew something was wrong. Hold on, let me just write the factors and then we're good. X minus 1, x plus 5. Beautiful. So these equations look very different, but I promise you, they represent the exact same thing. They represent the exact same quadratic relation. One is in factored form, one is in factor form, one is in vertex form. But you know what? They are the exact same equation. They just look different. It's very similar to what you did last year when you did standard form of a line and a slope-intercept form of a line. They look very different, but they represent the exact same line. Okay. And later on, when we upgrade our algebraic skill, we can prove that these are the same by expanding and simplifying and putting them both into standard form. Okay, so let's tackle some word problems now. So we have a parabolic tunnel that's 25 meters wide and it has a maximum height of 30 meters. How high is the tunnel when it is 5 meters from its base? So there are actually a lot of different ways to do this question. I'll just show you one of those ways. And it's really how you want to imagine this tunnel. So when I imagine this tunnel, I'm putting the edge or the one of the bases of the tunnel on the origin. Okay, you could draw the tunnel where the vertex is on the y-axis if you want. But you know what? Either way, you'll get the same answer. So I prefer to put it the base of the tunnel on the origin. Okay, this tunnel is 25 meters wide. So this number here is 25. This is 0, and this here is 30. What's very important is you know this number here is 12.5. So that means the vertex, the way I've modeled it, is 12.530. So now we can find out how high it is 5 meters from its base. Okay, you can either go 5 meters from the left base or from the right base. Let's say from the left base. So 5, and then we have a question mark here. How high is the tunnel? 5 meters from the base. We can find out how high it is if we had the equation which models this tunnel, right? So let's see, should we build the equation of this this parabola in factored form, vertex form, or standard form? Well, you actually have some options. You can either build it in vertex form or in factor form because you have the x-intercepts and you have the vertex. So I will build it in factored form. So y equals a, x minus r, x minus s. Let r equal 0, s equal 25. Sub in the point, 12.530. Okay. I won't skip a step. Okay, so this is negative 156.25a. So a divided by that, or sorry, 30 divided by that will be negative 24 over 125. And when I see that that negative, I'm very happy. Because look at this, it's open down parabola. It better be negative. So therefore, y equals negative 24 over 125 x minus 25. Okay, that's the equation which models this parabola. which also represents the tunnel. Now remember, the question has yet to be answered. How high is a tunnel 5 meters from its base? So I have to let x equals 5. So let x equal 5. So y equals negative 24 over 125 times 5 minus 25. Let's see, how high is a tunnel 5 meters from the base? Now, to be honest with you, you could have went 5 meters from this base, so you would let x equal 20. Now, based on the symmetry, when you let x equals 20 and when you let x equals 5, you'll get the same y coordinate, okay? If you don't trust me, just punch it in, and instead of doing 5 here, do 20. 1 second here. And if you do the math, you get 19.2. Therefore, the tunnel is 19.2 meters high, 5 meters from its base. By the way, it's really silly to shape the tunnel as a parabola. Yeah, just not very used to your space. I mean, I'm not an engineer, but maybe there is a circumstance where it's a good idea, but it just doesn't seem like a good idea. Anyways, let's see, next question here. Toy rocket. It's launched into the air from a hill and reaches a maximum height of 840 meters after 3 seconds. The rocket falls to the ground after 11 seconds. How high is the rocket after 4 seconds? All right. You know what? A picture has never hurt anyone. So you launch it from a hill. Okay. Whee! Goes up, 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 and down, 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 down. So after 3 seconds, you reach a maximum height of 840 meters. So guess what? Your vertex, you know what that is. 840. It falls to the ground after 11 seconds. How high is the rocket after 4 seconds? So let's say this is 4 here. So this is the point that I'm looking at. Right? Just like before. How high is it after 4 seconds? I know how high is it after 3 seconds. So I don't know what the height is after 4 seconds, but I'm very sure that it's less than 840 because the max height is 840. But if I had to guess, I don't know, 800? I don't know. Let's see. So, what am I going to build this equation in the form of, let's see, I have choices. Standard form, factor form, or vertex form. Well, unfortunately, this one I have to do vertex form because I have the vertex and I don't have both the x-intercepts. Actually, I can. It's actually 11. So if this is 8 units apart, the other one will be at negative 5. Ooh, my scaling was horrible here. I'm sorry about that, but it's going to be negative 5 as my other x-intercept. I could, yeah, because that x-intercept is meaningless, okay, because I haven't even launched a rocket yet. But I can use that to build my equation. Saying that, I'm still going to build it in vertex form, because in my previous example, I built it in factored form. Okay, so vertex form, let h equal 3, k equal 840. I'm going to sub in the point. Okay, please don't sub in the vertex. You can't sub in the vertex because you've already used that piece of information. So you have to sub in this point here, 11, 0. Okay, that's all for A. 11 minus 3 is 8. 8 squared is 64. So A is negative 105 over 8. So therefore, y equals negative 105 over 8. X minus 3 all squared plus 840. Now, just like before, having the equation is great, but I still have to answer the question, which is how high is the rocket after 4 seconds? So let x equal 4. Okay, So let's see. 826.875. Therefore, after 4 seconds, the rocket is 826.875 meters high. Beautiful. So really connect what you did last year with what you're doing right now. You're really just solving the equation. Now be careful, you can solve it into vertex form, factored form, or standard form. Now, we really have done standard form injustice. Now, I will go back to it. We very rarely will you build the equation in standard form because I guess I'll spoil it. Standard form is not really good. Standard form really gives you one piece of information, okay, which is the y-intercept of the parabola. And of course, A is, you can extract that from any form. So yeah, I guess you can say, I know what the stretch factor is or compression factor, I know whether it's opening up or down. But really, aside from all that, you know the y-intercept and it gives you nothing else. That's why we hardly ever build the equation in standard form, because the information we have lends itself to vertex form or factored form. Yeah, so over time you'll realize standard form is really poor. But in the homework question, we have a really good question that we build the equation of the quadratic relation in standard form. So please do the homework because it's really good practice on this sheet.